So what would happen? The electrical grid always needs to be in balance. So you always need to feed in the same amount of power as is taken off. And to do this, people have been making forecasts, but the general idea is you have the expected amount of demand and nowadays also the expected amount of supply. But before that, it was just you had a couple of large coal or gas-fired power plants that were flexible and you could just ramp them up or down depending on the demand. Why? Because you need to balance supply and demand. Now the system changed and you need to forecast supply, so wind power generation, solar power generation, to then take actions to balance the net. What we do is we forecast solar power generation, wind power generation, real time up to a day ahead, as well as we forecast prices, right? So short-term power prices to provide trade strategies to companies on how to effectively make most money with your assets.
Welcome to Inspiring Computing. This podcast is where computing meets the real world. Inspiring Computing aims to trigger your curiosity by talking to proficient and advanced MATLAB, Python, and Julia users who use these tools to deepen their understanding of the world around them by simulating it, exploring trade-offs, and gaining insights that help their companies add more value. In addition to proficient users, we will be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives their development and what issues they're solving for others to benefit from. Welcome, Tom, to Inspiring Computing. I came across your profile because a friend of mine told me I had to speak to you. And looking at your LinkedIn profile, I have to ask you, how does an aerospace engineer become a chief product owner of a fast-growing energy company powered by AI? Tell me the story behind this, Tom.
First of all, thanks for having me. So the background, I studied aerospace engineering and wind energy engineering. So that's how I rolled into the energy sector. I noticed that I was particularly interested in not only how you build the wind turbines, but especially also on how to integrate them in the system. And that mostly happens on power markets. So that's where I actually started my career at the energy company, at the trade floor, working on fairly comparable things as we do now. Generation forecasting for short-term power markets of wind and solar power, price forecasting. You forecast prices because it's a good proxy of what the net needs, right? If there's a shortage of power, prices go up. If there's an excess of power, prices go down. That's how you're incentivized to help balance the net. And portfolio optimization. So thinking about how your entire portfolio participates on the net, essentially. I love that. I really enjoyed working in that space. So after working as a data science consultant for some time, I then decided to go back to the energy sector because I missed it and I wanted to be part of it again. I love the problem space.
So then tell me, then you created a company, Dexter, or you're one of the founders, or you're one of the early joiners? Tell me the story of that.
Yeah, that's right. I'm one of the early joiners. So 3.5 years ago, I joined Dexter Energy, a company that provides generation forecasting services like I just explained, and trade optimization services. And to me, everything came together, right? So it's a problem space I love, using the toolbox I love using, data-driven solutions. And it's I love this entrepreneurial environment where we just make solutions where the results matter more than the progress, right? The big difference to my mind between big company and small company.
So I want to double click there on a whole bunch of interesting things. So maybe just to guide this a little bit, you mentioned that you one of the early joiners of a very cool company. We'll get into more details of what your company does and how you're doing it. But you're also a predominant Python programmer. So just out of curiosity, how did you get exposed, or where did you first get exposed to Python? And how did that influence your decision criteria at Dexter Energy?
I think I first got exposed to Python during my studies, my master's. Started using it more and more after that. To my experience, most of the machine learning data science community lives in Python. So for me, that made most sense. As the entire community lives on that tool, that's just, you just go with it. Also made venture into things like MATLAB all the way at the beginning, R, worked a bit with that as well.
Yeah.
But in terms of actual modeling, that was mostly Python for the start. Yes.
So when you joined Dexter, my understanding is you're the lead data scientist or the mathematician behind the starting point of Dexter Energy. So tell me a little bit more about what actually you do. So you name dropped a few things like energy forecasting, trading. So for those of us who don't live and breathe this environment, can you explain what does actually Dexter do?
Yes, I can. I'll take a step back to explain why we do what we do. You have to understand that there's the energy transition going on, where the transition, the hardware transition is the transition going from carbon-fired steerable generation to a renewable-based system, which is a transition from a demand-driven system where you adjust supply to demand to a
Yeah.
supply-driven system where you have to add all sorts of flexibility in your system because your supply is non-steerable and intermittent, right? So way back, you had this very stable forecast of what the demand of industrial and household users would be in terms of power and gas. Now let's focus on electricity. So what would happen is electricity, the electrical grid always needs to be in balance. So you always need to feed in the same amount of power as is taken off. And to do this, people have been making forecasts, but the general idea is you have the expected amount of demand and nowadays also the expected amount of supply. But before that, it was just you had a couple of large coal or gas fired power plants that were flexible and you could just ramp them up or down depending on the demand. Why? Because you need to balance supply and demand. Now the system changed and you need to forecast supply, so wind power generation, solar power generation, to then take actions to balance the net. What we do is we forecast solar power generation, wind power generation from real time up to a day ahead. We forecast power generation as well as we forecast prices, right? So short-term power prices to provide trade strategies to companies on how to effectively make most money with your assets.
So let me see if I get this straight. Me as an individual user, I have a contract with a power company and I pay a fixed fee per month, or there's different ways of doing it, right? But this company in turn, on a daily basis, they're always looking to make the most money, right? So the price of electricity is not constant and it depends where that energy company gets their electricity from. And if it's from renewable or coal or non-renewable carbon, the price changes. And the idea is if it's getting it from renewable, be that solar or wind, they need to know how much is available. And that in turn impacts the strategy of how much wind electricity I buy or trade at a certain point in time with a 24-hour outlook. Is that kind of what you're doing? And you're giving the insights to these companies to say, no, don't buy wind, buy solar. It's cheaper because, by the way, the sun is shining and it's going to be shining for the next 12 hours. Is that kind of what you do as a company?
First thing is indeed, we forecast expected production of their assets, or how much wind and solar will their assets produce, because it's also mandatory for them to share this with the grid operator. They have to make a promise, this is how much we'll produce. If their forecast is off, then then the grid operator will take care of this and they will balance the net for them. That on average costs them money. I say on average because if you're actually on the right side of the system imbalance, then you make money because you help balance the grid. That is how it works in most European markets. Now, the key insight here is that energy has a different price depending on the exact time of usage. It's a wholesale market, so everything goes like on one big pile, and the combined megawatt hour that has a value. So you can't decide whether, I know that's how they sell it, but usually you can't really choose on a wholesale market what power you buy exactly, right? The market is just cleared as a whole. The key insight is that power has a different price per time of usage. And that's what you can make use of. And it does also has a different price depending on which market. So if on day ahead you expect there to be a certain amount of wind power, a certain balance in the grid, right? The grid will be balanced. But then on the day itself, it turns out that it's much more sunny and much windier, and there's an excess amount of power on the grid, then prices drop, go down. And if you're then producing more than you promised, you have to produce that power at a much lower price, even negative prices. That's quite frequent nowadays, actually. So then you have to pay money to produce or to supply excess supply to the grid.
So this, from a mathematical perspective, it's much more complicated than forecasting a balance sheet of a company, because it feels like there's many more moving parts and components and players in this. So if I get this correct, you're using AI to help companies understand what the is going to be, and in turn, you optimize their trading strategies to buy and sell and when to buy and sell, because it's not I buy today or I sell tomorrow. It could be I buy in an hour and I sell in 3 hours kind of thing. Is that kind of how it works?
So what we use machine learning for, and we build data-driven products for, is for the generation forecasts, right? Where we translate data, historic data, weather forecasts, historic power measurements, characteristics about the wind turbine or solar park, where we translate this into expected power output up to a day ahead in a time series with a 15-minute resolution, to be very precise. For every 15-minute block, we output megawatt hour for a portfolio or for an asset. Do this on asset level, and then you can aggregate to a portfolio level. That's the generation forecasting part. For the trade optimization part, you can choose on which of the short-term power markets you buy or sell your power. So you can sell a bit now, sell a bit later. But the main difference that people should understand between power markets and, for instance, stock markets is that it's a physical market. There is a time of delivery where you actually produce the power and where the market is cleared. And the resulting power has to be zero.
So you've described 2 products/services that you provide your customers. Can you maybe tell me a little bit more about some of the maths behind this? So you said you use AI. So is this just simple forecasting, or is this like part of your secret recipe?
For the machine learning oriented folks listening to this, it's a fairly familiar cycle, right? Where you go from data all the way to model output to product. And essentially we, like, first and foremost, we put a lot of attention, love and care in our data, right? In the data we get from our customers, the data we get from the market, such as price data, interconnectivity between markets, and weather forecasts, right? That's just 3 of the main data sources. And then we take a lot of care of cleaning this data, getting it in a good shape. Yeah. There's a lot of post-processing going into this data, not only to get it clean, but also in the right format. After which the modeling part starts, right? Feature processing, and then there's the part which is the actual curve fitting, which is essentially the modeling of a physical process, right? So the generation forecast is the translation of, for example, wind speed to power output, or expected market state to price, or power forecast and price forecast into trade decision, right? That's the type of decisions that we help with. And generally speaking, many things we do has a very strong time series component to it. Everything we deal with has a time component. So lots of time series forecasting, regression, some classification tasks. It's quite a mixed thing.
Would an energy company themselves not do this, right? So you've created a company specifically to help other companies do this. Why is it that, I don't know, the current energy companies aren't doing this in-house?
Yeah, good question. First of all, they do this in-house, or at least some of them do. Just like every other service you can buy, at some point there's just economies of scale, right? We do it for more companies. We can pour more resources into doing the one thing, so we get better at it. The one thing that every energy company holds over us is they know their assets better than we do, essentially, right? So that's something that we collaborate and we invest a lot of time and effort into understanding the assets, the data better and better. Why do they outsource it? Because we at least try to be better at it. And that just has to
Right.
do with the economies of scale, right? So we are able to make use of more weather models than would make sense for a energy company. That's expensive.
But does it depend, for example, on the more customers you have, the better models you can produce, because that you can leverage multiple of your customers to get to better insights? That you
There's
can,
this transfer learning as well, right? Like at some point we've just seen more assets than a typical customer would have. Yeah.
and just to be clear, so you're based in the Netherlands, right? So your company's in Amsterdam, if I'm not mistaken.
Yeah.
But is this just a Dutch thing? Is this just happening in the Netherlands? Is this a European-wide problem, or is this a global problem, or does every region tackle it differently?
Generally speaking, every liberalized power market in the world requires a service like this. But also for non-liberalized countries, like you need to know the amount of demand and supply to be able to balance an electrical grid. However, the services we provide are mostly interested for liberalized power markets with lots of renewables.
So given that you've always been a product company, so can you maybe talk a little bit about how do you decide what makes it into a new feature, and how does your release cycles look like? If I understood correctly, you get a lot of data, you combine multiple sources, you do some data cleaning, you train your models, and then you have something that a company or customer purchases, right? How do you decide what comes next and what to add, and how long does it take?
That's an infinitely deep question. First of all, what constitutes as a new product? For example, wind power forecasting is a product, solar power forecasting is a separate product. And then there's a more detailed question: is intraday forecasting a different product than day ahead? It's a definition question. I don't really care. But so how we go about deciding what new product we should develop that's always a question of how do you prioritize, right? So that's a matter of assessing what the customers need,
Right.
what's the biggest pain, what ideas have the highest expected return on investment, and then we pursue those.
So if we were to zoom in like on the solar powered aspect, right? I'm assuming that in the Netherlands, at least, more and more people are buying solar panels, right? So I think at a
Yes,
mass level, that must have an implication, right? So
yes.
does that change the maths and your modeling? And does that mean that you have to update your models on a much higher cadence than that you initially perceived?
Yeah.
Or does it mean that you need to get more data sources? Tell me a little bit about that.
Yes to everything. Yeah. So it's a rapidly changing market, right? It's the energy transition. So stuff is changing. The change itself is fundamental. How we like how we produce energy is changing. So the system change is huge and it's very rapid. I don't think a lot of people have, at least if I talk to friends and family, they're always surprised by how fast things are actually changing. It's not something in the background anymore. The change is massive. So what that means for a product, to give a more technical answer, is I think the lowest or the slowest update we have in terms of model training is once a week, but most models are retrained daily or even more frequent because the system is changing, because we've noticed that there's just a lot of value in highly adaptive models. Only take solar power, which is actually a very interesting example. Every year at the beginning of spring, the entire market is surprised by how much more solar, rooftop solar, and also in the, large scale solar is installed. And the impact this has on the grid is not to be underestimated. You just see sort of large peaks of excess power still actually every day between, let's say 1 and 3 or
Hmm.
yeah, because it like the growth is so rapid. So you need highly adaptive models to be able to capture that change.
So I'm going to put on my Python hat. So every year there's a new Python version, right? So every year there's a cadence, and many software companies slash product owners or package developers will keep a steady cadence and a predictable cadence. But I think in your industry, if I understand correctly, it's not that a company buys product A and it's stable. No. So part of the value that you bring is that your product is continuously changing on the background and at a much faster pace than people really realize. And the fact that you're estimating things on a 15-minute scale means that you must be very precise and clear of what you're doing. But that itself lends it to a huge engineering challenge of building out a team to make this a reality. So can you maybe talk a little bit about the tool chain or the technology stack that you've got in-house to make these kind of things a reality, to make it easier for yourselves? Or maybe a few war stories that you've gone through.
War stories, yeah. So first about the tech stack. So we're I should call it a Python shop. Almost everything we do is in Python. Also the engineering part. We're on Google Cloud. We use a large variety of managed services, but like the typical micro setup. So from like Kubernetes, Docker, Helm, we use Airflow for scheduling some of the tasks, many different databases, because there's many different data formats we store. One of which I think is very interesting and a huge, which is weather data. That's terabytes of data constantly coming in, being updated. But all of that is done with Python in terms of like the main language.
And so just to double click there on the weather data. So where do you actually get the weather data from? Is this an open API that you're pulling from? Is this proprietary? Are you paying for this? Are you plugging into multiple weather stations around Europe? I'm curious how you make that decision.
Yes, we're a very data hungry company, right? Because it gives us more potentially new signal. In that sense, we also have multiple weather models. So we have a couple of global weather models, ECMWF, which is the European one, GFS, which is the American one. And then there's a whole lot of local weather models, a German one, a Dutch one, a UK one, a French one. And like we just download what's useful on a regional level and we make use of it. And then how we determine whether it's useful, that's obviously the beauty of data-driven products, right? You can just, you can backtest it. What would have been useful.
I see. So tell me then a little bit more about the testing. So I guess you have a baseline of when you're happy with the result. How do you set these baselines? And then how do you know when to make things better? And how do you know to say, okay, the Dutch model was a little bit off. We should have maybe used the Benelux model because that was a bit more sturdy at this moment. How do you make those decisions?
Yeah, so the decision on whether to accept or reject the model change is very dependent on the maturity of the product, right? So if you start prototyping, you need to think of a baseline, like something very simple to be, which for weather forecasting is always the weather doesn't change, for example. Now we don't do weather forecasting, so that's a bit of a silly example. But you can, for instance, for wind power forecasting, you can make use of a very simple parametric model or a power curve lookup model. Given this wind speed, you'd expect this much power out. We've fortunately passed that stage a couple of years ago. So now we can really iterate on the models we have, right? Is it better than what we had before? And even better, can we benchmark it against competitors' performance, right? We can just ask customers, are we out competing our competitors? And then we hope for a yes. Unfortunately, that happens. And every time a customer makes a purchase decision, they make this comparison. So they ask us two things. What would have been your historic performance? And then we provide them a back test, a hindcast, and then they can compare it with what they have. And that's like the first thing they ask. And then after that, there's typically a live pilot during which we show them what we've got, but then live in production. And then they can just compare it against what they have. It's a time series. So you can just compare how accurate was your forecast against the other forecast. And for all the trade optimization products and the asset steering products, you can also just see how much money did it make. Was it better or worse than the alternative? So everything is extremely data driven and there's not much room for guessing. It's just better or worse, which is very nice.
Yeah. So that gives you a solid grounding point to know if you're iterating towards a good or a bad place.
Yes.
Because just from my understanding, your business model, the way you make money is, I'm assuming you make money when your customers make money, at least on the trading side. So I assume you take a small percentage of their profits along the way. So it's in your advantage to maximize your customers' profits because you also maximize your profits like that, right?
Yeah, of course. Yeah, we try to align our incentives, right? Such that they benefit, we benefit. And in terms of generation forecasting, the more assets we forecast, the larger portfolio, the more we charge because it's more work. There's more compute costs. So yeah.
So often what happens, or a question that I've heard a couple of times in energy trading is, what happens if you become big enough that you actually have everybody as customers? So if all of the energy trading organizations are your customers, you become like, you can fiddle the system, right? Is that something that you actively work not to happen, or you're not or that's not a concern?
Yeah, great question. For generation forecasting, it's a different product than for taking
Right.
trade decisions, right? So for generation forecasting, you could theoretically serve the entire market without a problem. That's not a problem because everyone just wants to be as accurate as possible on what their expected production will be. So if you're by far the most accurate, then why not use it? From a system perspective, there's a downside to it because then you have one market serving party. And if they're wrong, everybody's wrong, right? So the
Right.
forecast errors would then be highly correlated. So that's one thing that could be considered an issue. On the trade optimization side or anything that has to do with market participation, there's option, obviously a finite depth to the market, right? At some point, you flip the market and a surplus becomes a shortage, for example, right? So there's a certain depth to the market. And I'm pretty proud but about this, to be honest, but we've worked quite hard on being able to estimate to what extent we impact the market and how deep is the market? How does price elasticity work? How can we optimally help balance the market? That's what it's about, right? You want to help
Right.
balance the market. Once you start hurting the market, you don't make money, you lose money. So by participating in a clever way in the market, you always help balance the market. That's how they're designed. If you help
Hmm.
bring more imbalance to the market, you have to pay. So you can't make money doing that. So that's why actually by aligning our interests with the customer interests, so they make money, we make money, we help the customer, we help the grid, and we help ourselves. And to do that,
Right.
we have to estimate the market depth and price elasticity.
Ah, I see. Okay, so the way that you phrase the problem is actually interesting, because you could argue that if you're helping all traders, right, making better strategies, you could give a device that would force an imbalance to the whole energy market itself, and that would actually hurt everybody, right? The way you're thinking about it is not about hurting everyone, it's about the energy balancing out as best as possible. And when that is done, then everybody wins. Anything short of that causes problems long term. Is that kind of the philosophy?
Yeah, so for every market participant, unless you really try to game the market, for which there's not a lot of examples, if you help balance the grid, you make money. If you bring imbalance to the grid, you have to pay. That's sort of the
Right.
fundamental. To keep it simple, that's how the market is designed.
And just from my understanding, when you say imbalancing the grid, you have to pay. How expensive is an imbalance? So I have difficulty grasping of what that would actually mean. It's not, oh, it's going to cost a couple of euros here and there, right? This can get significantly expensive, right?
Yes, yeah. So for the entire European market, so for its multiple billions of euros in terms of imbalance cost for renewables, it's a non-negligible pain. Yeah.
So it's interesting because I never really thought of it. And I'm assuming also with recent economic fairs, the energy pricing has gone a little upside down, or things have fluctuated faster than many people could have imagined. But I guess that's actually good for you. And you being a scale up company, which is growing rapidly, I guess you can cater for these challenging times to be very quick and nimble on your feet. Is that also part of the benefit of what you're bringing to your customers? That if something's not going right 8 hours later, you're in a much better position?
Yes, to a certain extent, yeah, you're right. Being highly adaptive in terms of modeling is very important, like retraining frequency. I think the other thing that's actually as important or even more important is we're forecasting a physical system, right? So to be able to participate in it, you need to actually model what happens physically. Like you need to understand the drivers, what drives system imbalance. That could be a surplus of solar on the grid. It could be the fact that the border connectivity is limited. For example, there was a software issue causing that no power could be exported to Belgium on a super sunny and windy day. And that was very painful on the Dutch net, right? Prices went deeply negative. So, and why am I saying this? Because retraining your model, yes. Making highly adaptive models, yes. But first and foremost, understand the problem that we're trying to encode. That's very important as well.
When you say your models, it's not that you're making physical models of wind turbines, right? It's not that you have with a dynamic system of kind of create, okay, this is what one wind turbine can generate. You don't model the impact of wind turbine farms and the interference of the wind, and if it's going from east to west or something like that, based on the positioning, that could increase the amount of energy produced. You don't have mathematical models of the wind turbines themselves or the wind farms. You really look at it as a holistic level, at a system level. Is that
Yeah,
what
so
you
it's
mean?
statistical models. Yeah. Statistical models, not physical models. We don't physically model a wind turbine surrounding.
Tom, you name dropped this term hindcasting. So tell me a little bit more about what that is and how do you actually do that correctly and test for it?
That we care deeply about. Hindcasting means that you estimate the forecast accuracy would have been on historic data. So that's an offline test. And that's actually one of the nice things. We can do that quite accurate because you can simulate what data would have been available, what models would have been available, and you could simulate what the product would have done at that time. And especially for instance, the generation forecast, we can fairly accurate simulate what would have happened apart from production incidents, of course. But you can definitely model the happy flow quite well. So a few very important things there that we have noticed are first, you need to be able to access the data in an offline setting, how it would have been if you would have used it online, right? So in production. And I think what we are bringing here to the market and what I've experienced is that you need a whole lot of timestamps. You just need to timestamp your data. You need to version your data, right? So every time new data comes in, you also need to keep the old stuff. And this is what I've noticed that especially our market is struggling with still. So we store data every time new data comes available, but we also keep the old ones. We store when the data would have been available. So this means
Ah,
you store a lot of data, a lot of older versions, but together with the timestamps, then you can iterate through this data to exactly how it would have been available at that time. Of course, that is something very critical in this process. The other thing is that in terms of testing your model, right? You need this. Sure, some of the modeling folks will be familiar to this, but it's called time series cross validation, right? So you iterate forward in time. So you only give the model when you're training the model, you only give it access to historical data. You forecast a time step ahead. You move your training window one step forward, adding, for instance, one more day to the training period. Again, forecast one day forward, etc. So that's another thing that's very important. And other than that, you just need to version your entire pipeline, right? So to make sure that you are very much in control of what you use to make that hindcast, such that you can also figure out you end up with these results. And then the last step there, sorry, go ahead.
So I was going to ask you that if you could double click there on pipeline and versioning your pipeline. What does that actually mean? Let's start with what is a pipeline? So when you use the term pipeline, tell me what you understand as a pipeline.
So everything from data ingestion to kicking off your model to your feature engineering code to your model training code, like everything, like just the versioning of every different component that is in the code you use essentially to, if you do so, storing a trained model, right? If you then use it
Right.
in production, so that, okay, these are all the components that I used at that time to make this forecast, which is less relevant when you're making a reliable hindcast, but it's very important when you're making, like, for having like a reliable production setup or being able to store trained models.
Because that's something people underestimate, the amount of effort that goes into that, right? And if you
Oh,
want to
yes.
do Hein testing, you need to be able to reproduce exactly at a specific point in time. And sometimes you take it for granted that we now know everything, but at the time we only knew a small percentage of it. And that, I assume, can really change the maths. And setting that up, I don't think it's such a trivial task.
Yes, especially the data. So one of the key things that like the end-to-end test essentially is where you end up comparing offline and online results, right? This is how, for this specific point in time, if you then also have a production model running, what the prediction would have been using an online model versus how would this prediction have looked like if I have generated in an offline setup. Those need to be the same, or at least as
Yeah,
similar as
yeah, and
possible.
yeah. So that testing is something that you probably grew into. I'm assuming you didn't start with that at day one, and you've evolved that as time has progressed,
Oh
right?
yes, yeah, for sure. Yeah, many very painful chases for bugs eventually led up to the fact that okay, our offline performance is not the same as our online performance. And that had to do with both the components I named just now, especially the
Yeah.
data versioning. You have to do that extremely accurately. And yeah, it really pays off investing in these components. Once you have a product, of course, that is worth the investment in the first place. But to be able to make a reliable hindcast, you have to do this. Otherwise, you're just
Yeah.
fooling yourself.
So sometimes you hear a lot in the news, and people who are maybe not such strong data scientists, they believe that the elegance and the beauty is in the model itself. But actually, the important part is maybe not the models that are generated or trained, but actually it's the data that you as a company have access, that you're feeding to it. And the better the data, the better organized, the better structured, the quicker iterations you can go backwards and forwards. That is actually where more benefit comes, as opposed to tweaking model A to make it a little bit better. But if you got much better, much cleaner data, that has a significantly bigger impact in business and general outcomes than saying, okay, we'll choose this neural network versus that one, right? Or
Yeah,
is that?
no, I absolutely agree. Good point. And to build on that, I actually also think that like the quality and how you store it, that's important. And next to that, also understanding what this data is, right? How is it generated? When is it valid? When is it unvalid? So that like understanding where the data comes from. And
Chasing that pipeline, right? So it's a bit like when you buy a phone, right? You can look at the phone, is this good or bad, but understanding where the components come from, who designed them, what took into place, that actually makes the phone a better or worse phone, right? If you go down that storyline, it gives you, there's a story behind this, and do I truly understand what's going on?
yeah, absolutely. I think that's what I meant. We invest a lot in data quality, understanding the data, understanding how the data was generated. For example, like when you just received the actual production time series of a wind park.
Yeah,
It's a pretty neat time series, right? You have 96 points per day. You can have that for a year. It's just a pretty smooth time series. But what you don't know is what happened to this wind turbine. When was it in maintenance? When was there icing on the wind turbine blades? When was there an issue with the data measurements, right? All of this
yeah.
stuff, that's what really so much of the value comes from understanding that.
And I guess you also share that and that rationale also with your customers, right? So the fact that you can do that, your customers also appreciate the depth of which you go to build
Absolutely.
confidence. Yeah,
Yeah.
yeah, yeah.
Yeah. I think that's really important. And also, I believe we can more often than not give our customers insights into their own data, right? Because we take so much care of it that we really go super deep into what's happening. Is this turbine behaving according to expectations or is it doing something else?
Deviating. Yeah, yeah. Interesting. Very good. It's almost like you could say, hey, maybe maintenance is up. You don't know it, but this wind turbine needs to maintenance.
Yeah. And this is like the other way around. Hey, this turbine is in maintenance or it's not. Like this is maybe hard to grasp for some people, but it's one of the tricky things is that people performing and planning maintenance are not always the same or are typically not the same people as responsible for trading the volumes on the market, right? If you're trading the volume of a wind portfolio, it's useful to know when part of that portfolio is in maintenance, for example. However,
Right,
you
right.
see it coming, this communication isn't perfect. So when we get expected or scheduled maintenance. In reality, we find that usually this data isn't super accurate because they told they'd be there between, I don't know, 9 and 11, and they end up being there between 11 and 1. So then you're completely off, right? So you forecast lower production and there's full production. And then when you expect full production again, there's actually lowered production. So that's like the impact of the actual thing happening to the data, which if you just take it
Makes
for
a difference.
granted, you never see it.
And then maybe to talk a little bit about the future horizon for Dexter Energy. So it seems that you're doing this successfully, and I guess you got your VC funding, so that enables you to break into new markets. But what else have you got on the horizon that you're looking forward to seeing become a reality in the future?
I guess what I'm excited about is the fact that the more, like, the better our products become, the more positive the impact is that we're going to have, right? Years ago, when we were still extremely small, then that felt so far away, but now we're getting bigger customers. The products are getting better and better. We're really doing something. In some cases, we're really doing something better than competitors. So we're bringing something to the market. So just having the actual positive impact on energy transition, I think that's something that I'm probably looking forward to most, because I think that's super cool. Like, it's a direct link between how well we do to, first, how much renewables can you integrate on the net? Because if your forecasting is horrible, then there's a certain limit to how much megawatt installed capacity a grid can facilitate. So our services allow more renewables on the net. I think that's something that I'm looking forward to. And the other thing is that we do this also by just improving the business case of renewables, right? If you make more money with your existing wind portfolio, you're more inclined to build more. So how are we going to do that in terms of product development? We're going to roll out the product geographically to other countries. We're going to also start new product lines. For example, you can do day ahead, intraday imbalance, and we're more active on certain markets now than on others. It's same for wind versus solar forecasting. We're going to put emphasis on new products there as well. And there's always a certain thrill to developing new products, right? Something new. That's something that I'm definitely looking forward to. And then there's just the fact of growing the team, because it's not so much that I enjoy having 80 people around rather than 40, but the fact that the team grows gives you new velocity, right? So from that perspective, you can solve problems faster, which is nice. And the other thing is, I'm extremely impressed by the level of candidates and colleagues. I'm excited and proud of the level of the people that work at Dexter already and that are applying now. I think that's super inspiring.
I think it's very clear also on your website and the way you articulate things. Your goal is greater than just being good data scientists creating good products. You're much deeper in making the world a better place. And that comes across very clearly, that you have a tangible impact on the world, specific energy, and people can relate to it, maybe not understand it, but you're enabling people to make a real difference. And not every company on the planet can have such a direct connection, right?
That's amazing, right?
And that probably also attracts a certain profile. Maybe just out of curiosity, if some of the listeners were looking to explore working or contact you directly, what would be the right way to reach out to you?
I think easiest is probably LinkedIn. That's something that probably most people will know, right? You can find me on LinkedIn. If they're just curious to discuss vacancies, I would highly recommend you reach out to one of the recruiters.
What's the story behind Dexter, the name? Is there a backstory behind this?
Yeah, maybe some of your listeners will still remember the Dexter Laboratory, like the cartoon.
Seriously?
Yeah,
Is that where it's from?
Yeah, that's where it's from. Yes, I think so.
Oh, very good.
So. I do think so, that the time they agreed on the name, I'm not entirely sure how much thought they put into it. I think they liked it and then just went for it.
Naming things is important, right? Even for small projects, because then at a certain moment you can't change it too easily.
Yeah, exactly.
As your company's growing, and you mentioned that you're hiring a lot, so how do you, what type of profile do you look for, and what are the challenges in growing an organization? I'm curious. Not many people go through doubling up a company in the next year or so. Tell me a little bit about that.
I think the challenge is finding the people. And after that, growing the company in such a way that you don't disrupt teams, right? That teams don't actually lower in productivity. That like you need to have them grow in productivity. That's the challenge while maintaining the great company culture we have. That's the problem statement. So what we do is I try to find excellent people. That doesn't make the search a lot easier, but I really believe that makes our life better in every possible way, right? Like by having the best possible people are motivated by working side to excellent other engineers. I believe there's a snowball effect. Once you attract great people, they attract great people. And I care deeply about people that are aligned with our mission, right? That care deeply about the problem we try to solve and that have a passion for the tools you can use to solve the problem. And how we do this in practice is might be a bit operational to talk about, but you just need to have a great hiring process in place. You need to work with good recruiters. You need to, yeah, it's a very,
Fill that pipeline needs to work.
the people pipeline. You need to fill the people pipeline. And what I came to realize is that I already noticed, and I'm really noticing it, that this snowball effect is working, right? More and more people are finding us. The level of candidates is really high. So I also like that. And actually, almost everyone that comes to us is excited about joining this mission, right? They want to contribute. They want to do something that matters. They want to work in an environment where they can have impact, right? That's two things that typically matter to people, to working on something that matters and working in an environment where you can have impact. And that's one of my jobs, obviously, to make the organization such that very clever people can work autonomous and have impact. So and now I'm getting off topic a bit, but that's essentially what's happening now. So we're growing the team with these people, and it's very exciting to see who's joining while maintaining a careful balance to not grow the team too fast.
Because it puts a burden, right? So if you hire 10 people, your most senior data scientist now has to train 10 people. So he or she all of a sudden now has to find another X number of hours in the day to ramp everybody up, or the productivity of what he or she was doing has to go down unavoidably, right? So that
absolutely.
That is a burden that people underestimate. And do you have any advice for other companies going through this? Is there any concrete example of something that you did that worked nicely? I don't know. Did you give big bonuses, change salaries, do outings, force people to present at events, travel together?
Like I said, that's also like artifacts that are good, right? But I think the two things that I find actually help most is one, we work on something that matters and we create an environment where people can have actual impact really fast. You can work on the problem instead of struggle in an organization. I think that's the main thing, right? And the other thing is just company culture. People want to work in a nice environment, in a supportive, transparent environment with great other people. That's, I think, what eventually attracts most people. And then there's all sorts of way of doing this. Marketing, showing up in places such that people know you exist in the first place. But I believe those are the most important things, right? Create a work environment where people can thrive and have real impact.
But do things like let people bring their own pets? Or if you get the dog lovers, right? If you've got a dog and do you let them bring the dogs to the office? Is that what you mean by environment? Like cool lunches or things like this?
Yeah, but also that's all artifacts, right? I believe it's more about having things that people care about are being autonomous, being in an environment where people trust each other, be as autonomous as possible. So that's the stuff that really matters to people. And then there's all sorts of perks. I think we have amazing lunch served by a colleague. Milisa actually makes amazing food. Yeah, I'm okay with you bringing your dog, but that's all artifacts, right? That's to me not the core thing that matters is something else. Yeah.
This is a great place to stop this episode. I hope it triggered your curiosity in some shape or form of how MATLAB, Python, or Julia are actually used in the real world. If you did find it interesting, just subscribe in your favorite podcast player. And while you're at it, write a review, as this will help the podcast going strong. In addition to that, don't be shy, share it with a couple of friends, as who knows, one of them might be a future guest on Inspiring Computing. Thank you.